Good afternoon, everyone. I'd like to thank all of you for taking the time off your busy schedule to join us for the webinar today. So I'm very excited to be here today to share some of the interesting lessons and observations based on my personal experience working in the field of data analytics and AI. So here's the one second. Yep. So here's the agenda of today's session. We will start off by sharing some simple and useful frameworks or ways of thinking which help me make sense of what artificial intelligence and machine learning is. From there, we will explore on how AI is being applied in the industry today. Following that, we will examine on what some of the AI and ML tools in a modern AI toolkit looks like. We will also see how many of the tools nowadays have become very easy to use without the need for deep technical and coding knowledge. From there, we will conclude by sharing a training initiatives between NTUC Learning Hub and IBM, which we have collaborated on to help those who are beginning their AI journey take the next steps. All right, so now let's talk more about AI. Before going deeper into the conversations, I think it would be good to build a common understanding on some of the simple frameworks which I found useful to understand and make sense of artificial intelligence, as well as some of those commonly used terms. So we will start by examining what AI is. So what is shown on the slide now is one of the many definitions of artificial intelligence. So essentially, artificial intelligence is the broadest term used to classify machines that mimic human intelligence. It is used to predict, automate, and optimize tasks that humans have historically done, such as speech and facial recognition, decision making, and translation. So after going through many of such definitions of AI, what I find as a common denominator to what AI stands for is really about machines that are able of or they are capable of performing tasks which traditionally required some form of a human intelligence. Okay, so now let's break down the concept. I think first I wanted to break down on what intelligence is. So what is shown here are the common categories of human intelligence, which AI is able to perform to a certain level of competency today. So this includes the ability to learn, the ability to reason, solve problems, perceive the environment, and understand language. And I'd like to take two very basic examples of AI, which we have encountered frequently in our daily lives. The first one is any kind of a bot that is able to play games with a human today. So it has always been a big sensation when computer systems were able to beat human experts in chess, Go, and other games. So such AI systems will need to have the ability to learn from the past experience, learn from the examples that they have been fed on, then be able to do some form of a reasoning and solve the problem of coming up with the next best actions to win the game. Another example is iPhone Siri, which I think many of us were very familiar with, where it is able to hear our commands and actually talk back or respond to us quite effectively. So such AI systems like the iPhone Siri will need to have the ability to perceive inputs from the environment and also have the necessary language skills to understand our questions and execute the requests effectively. All right, so with that overall understanding, I would like to then delve in a bit deeper on some of the commonly used terms and how do they relate to each other. So on the right is a framework that I find very useful to think about AI. So if we really look at it, artificial intelligence is really the large umbrella that encompasses all the tools and components required for a machine to mimic human intelligence. So this can be any computing technology that exhibits anything that resembles some form of a human intelligence. And a subset and a big part of it is actually machine learning, which is essentially a type of algorithm that is able to sort of learn from the data by itself. So there are also additional terms that you might have heard of, such as supervised learning, unsupervised learning, reinforcement learning, deep learning, and so on. So I think like deep learning, those are essentially a smaller subset of machine learning algorithm, and they are categorized based on their mechanisms. So I think we have spoken that a big part of AI is actually machine learning. So now I would like to go on to the next slide to talk more about what exactly is machine learning. Okay, so machine learning is a form of AI that enables a system to learn from data rather than through explicit programming. So what this essentially means is when we feed data to a machine, it's able to learn on itself without sort of rules or codes being coded explicitly. So a useful way of thinking of machine learning is to think them of algorithms that you feed certain inputs, they learn from it. You feed new inputs, and then they will be able to give you the answers accordingly. So you can also view that as a question and answer machine. So essentially, at the end of the day, a machine learning algorithm is just you have certain questions or you feed certain parameters or inputs, and it's supposed to give a output. So there are two common examples that I would like to illustrate more in the diagram below. So the first one involves recognition of handwritten digits. So at the start, we will give many images. So these are images of handwritten digits. We will give the machine learning algorithm many images of such handwritten digits with the correct labels. For example, this will be 6, 7, and 1. And with that, this will enable the machine to learn and then correctly identify or learn to identify the correct digits based on the handwritten images. And after the machine has been trained, whenever a new image of a handwritten digit is fed into this algorithm, it will be able to, based on the image, identify the correct digit. Yeah. Another example that I like to highlight on is the spam email detectors that we are very familiar with. So whenever we receive spam emails nowadays, say on Gmail, automatically there will be a classification and send all those high potential sort of a spam mail to our junk inbox. So at the start, such machine learning algorithms would be given a wealth of examples containing the email text content and additional details like the senders, the location, etc. And at the end of that, they will also be fed with the correct labels of whether this email is a spam or not a spam. Following that, the machine learning will be trained on these examples. And then after that, it can be used effectively to classify whether an email is spam or not, similar to our experience on what we have on our email in the current day. Okay, and next, I would like to then use another simple example to further illustrate the point on what constitutes machine learning and what does not. So first, let us imagine that there is a task, okay, to identify whether an object shown here is a square. Okay, so one way to do that, or the traditional way that has been typically been done in the past, is by expert-defined rules. So expert-defined rules will involve programs that make decisions based on predefined rules using if-then logic. So in this case, for example, the sort of predefined rules can check whether the object has 4 sides, are the 4 sides equal, and the angles between each of the sides 90 degrees. And if it is, then it is a square. If it's not or it does not conform to any of those rules, then it is not classified as a square. However, this is not machine learning, as it is based on a human explicitly coding it and not based on a machine learning independently from a data. So using the same example, I'd like to then show how a machine algorithm would typically perform the same task. So for training a machine learning algorithm, we will first provide some positive examples. So in this case here, you can see all 3 examples here are squares in different sizes, different orientations. So with the labels that these are squares, we will send it for the machine to learn. In addition, we will also provide negative examples shown in red below. So these are essentially 4-sided figures which are not squares, like the rectangle, rhombus, and trapezium. So we will then have a negative labels to say these are sort of 4-sided figures are not square. After that, we will feed these examples together with the labels to the machine learning algorithm and let the machine learning algorithm figure out the patterns by itself based on the labels as well as the examples. So once the machine has learned from these previous patterns, it will then be able to correctly identify the blue object being sent as a square. So this is how machine learning typically works. You feed it some examples, it learns from the examples, and then after that, it is able to generalize from the patterns. Yeah. And next, I would like to shift gears slightly and also talk about the thinking about the impact of AI on humans as well as the future of jobs. So based on the current research, there is a consensus that AI, like many technological innovations in the past, will enable humans to take on higher value roles and tasks by enhancing human capabilities as the more mundane jobs are being replaced. So a commonly used term to describe this is augmented intelligence, where the role of AI is aimed at integrating harmoniously and enhancing human capabilities instead of replacing humans altogether. So from the research of the World Economic Forum, it is predicted that new technologies will bring about a net increase in jobs. This means that there will be more jobs being created by new technologies rather than jobs being displaced by them. So what makes it even more exciting is that entirely new roles, which do not exist today, will be brought about by new technologies. So these jobs are commonly termed as the jobs of tomorrow. So essentially, what we are seeing is that in the future, a machine will augment sort of a human worker and be able to enable the human to perform even higher value added tasks with some of the repetitive tasks or some of the thinking being taken up by the machine. All right, so now that we have established some ways of thinking about AI, I would then like to share about some practical examples on how AI is being applied in the industry today. So in today's context, AI applications are already widely adopted across multiple industries, ranging from banking and financial services to manufacturing and telecommunications, just to name a few. This trend is expected to continue to grow, enabled by the increasing capabilities and adoption of AI technologies. So in the next few slides, I'd like to dive deeper with a few interesting examples on how AI has been employed to make a difference, transform heavy industries, improve safety, and serve the general population. Okay, in my first example, I'd like to explore more about how the initiative between IBM and the Port of Rotterdam has brought about a major transformation. So the Port of Rotterdam is very forward-looking and is actively looking at leveraging on AI and IoT in its goal to be the smartest port in the world. So the basic idea is that by building on AI capabilities to their existing infrastructure of data collection, computing, and networking systems, they are already installed in various devices and various parts of the port today. So this can then create a revolution and reinvent many of the existing process and operations. So in the video that I'm going to show next, it is going to illustrate how IoT capabilities together with AI are making inroads to optimize operations, reduce cost and wastage, utilize building and infrastructure more efficiently, and enable green and sustainable initiatives. So let's take a look at the video to find out more.
Every day the tide is different. Sometimes it's higher, sometimes it's lower. We have a lot of wind. Everything has its impact.
The Port of Rotterdam is some 50 kilometers long, 3,000 companies, 470 million tons of goods, providing employment for some 385,000 people.
The port needs the digital transformation in order to survive. For them, it's crucial to become the smartest port in the world.
Across industries, smart technology and creative thinking are driving innovation around the globe. This is how the Port of Rotterdam is going the extra mile. I like to say you can't have AI without a digital twin. A digital twin is a digital representation of a physical thing, and all of the assets around us are becoming really intelligent.
The IoT sensors are critical to this.
IoT sensor is a lot of things. It can see, it can hear, it can touch, it can feel.
They measure everything from the water movement, tide height, vibrations, pressure, movement, temperature, turbidity in the water.
So we'll have better insights into how all the different assets and all the different equipment within the port are operating with each other.
We're using 5 different types of sensors throughout the port. You have to make sure that the data that you get is valid. And you don't want any disaster to happen because sensors are hacked or broken.
If you can start to digitize everything from the cranes to the ships to the quay walls and get the information from them in real time, your decisions can be made extremely fast and with much better accuracy.
The technology they're using in the control room is the IBM Hydrometeor dashboard.
We look at the information about tidal current, salinity, visibility, wave height, wind direction. The data is really helping me to get this ship in a safe manner. If I make the wrong decision, you could end up grounding the vessel, making a too wide turn, ending up in a collision with other ships. And that, of course, might have its impact on the environment.
All right, now let's move on to the next example. So the next example that I like to share is how IBM is working with Sunbelt, Denmark's state-owned infrastructure company, to manage their roads and bridges, including the third longest suspension bridge and world longest tunnel. So in a study commissioned in the US, it is estimated that 1 in 13 bridges today are in need of urgent repair and might be structurally unsound. However, the key impediments or the key challenges to having all these necessary checks is that today, having an inspection on an infrastructure like a bridge is really very challenging, and it is a very dangerous task, almost similar to climbing mountain climb, like tall mountains, where inspectors have to climb and scale the tall infrastructures. So this has resulted in a shortage of specialized manpower, where the capacity of companies are unable to keep up with those mandated inspections. So with the help of drones and an integrated digital platform, the inspection of infrastructure now is greatly simplified and can reduce the time required from 1 month to just a day. So let's now take a look at the video to find out more.
To the untrained eye, a bridge appears to be permanent, strong, stable, and it's not really moving. But this is an illusion. If it hasn't been inspected in the right manner and maintained in the same manner, a very sad accident can happen.
Maximo is a management system where we not only can write out work orders, but we see it as basically the foundation, the spine of everything we want to do from a digitization point of view.
The dream is that this technology can really help to reduce or maybe completely remove the risk of tragedies. Collapse of bridges, collapse of tunnels, collapse of buildings.
When we are having a bridge out in the sea, you have to be aware how the chloride is actually penetrating the concrete, because rust is one of the enemies for concrete structures. We literally have to hire mountaineers to climb the surfaces to actually do the inspections.
There are many disadvantages to traditional inspections. People's life is in danger sometimes.
Now we have changed that way of inspecting our concrete surfaces, from the mountaineer climbing around, using drones now.
Everything is done automatically. It's scalable. Scanning a bridge can take 1 day instead of taking a month.
All this data that feed into Maximo from sensor, from document, from images, and from other sources needs to be processed to extract knowledge, and that's where AI comes into play.
There's a huge stack of informal data, unstructured data, and we need a machine that's able to read and process unstructured information.
Maximo can do it in a fast way, in a repeatable way, in a scalable way, and once it learns to do the job, it learns forever.
Now we have a way to show a complete picture of the health of a bridge. And it's not every second year or every 6 years we can do that assessment. We can do it from second to second.
Okay, so I hope the sharing on some of these interesting applications of AI today provided a good sense on how AI has been making inroads at multiple fronts and making a difference. So in this next section, I'd like to share more about some of the tools that are powering the applications that we have seen. So first, I'd like to share on some common characteristics on some of the tools today. So I think many of these AI tools today are hosted in the cloud, like Azure, AWS, Google Cloud, IBM Cloud, and Alibaba Cloud, just to name a few. In such a setup, we will then no longer be limited by our hardware limitations because everything is hosted in the cloud, and we will always have the latest technology and computing capacity available. As long as we have an internet connection that connects to the cloud, we can leverage on all the infrastructure that has been already built up there. Also, moving to the second point, many tools today are very intuitive. They are very user-friendly, and we wish to make them very easy to use and very easy to get started. Also, many of those tools have been developed and refined to such an extent that for the common machine learning and AI tasks, there's usually no deep coding or technical expertise required. And many of those tools are easily customizable to be applicable for the user's problem in the user's context. In addition, many of those tools have already been pre-trained on huge amounts of data and optimized with complex models underneath the hood. So those have already undergone extensive training, best practices, and so on. So by using those tools, all that is needed is already just to fine-tune and just to customize sort of a few fine parameters to adjust based on the requirements. And it saves a lot of time and effort because there's no longer a need to build all this from scratch. And in my next few slides, I would then like to go more into details today, particularly some of these tools that are available on IBM Cloud and how they look like. So the three categories of tools that I like to go through today are tools with natural language capabilities, tools with chatbot capabilities, as well as tools with AutoAI capabilities. So first, let's start with the tools with natural language processing capabilities. Particularly, I would like to look at one of the subset of the tool, which is a tool that can generate a sentiment analysis. So here I use an example of an Airbnb review. So over here you can see typically when a user uploads a review, the data can come in the form of a JSON data structure as shown here. So essentially we can see that this is the attribute, like the listing ID, this is the value, this is the reviewer ID, the name, the location, and so on and so forth. And sort of the important part that we would like to highlight is that this is the review text. So this is the text that the users key into the review. So as you can see from the text here, typically we will see this as is generally a very positive kind of a feedback. Like we can see things like a great host, it was cool and relaxing, best place to be in, and so on. So the next step, what we need to do to have a tool to perform sentiment analysis on this is to one, feed all of these data into this IBM Cloud tool called Discovery. And then next, we will just select sort of the components that is required. So here we have select a few of the key components: keyword extraction, sentiment analysis, concept tagging, category classification. And it's as easy as just clicking the add button because all of this has already sort of been pre-trained. All of these are already ready to use. So we feed in the information, we click the components that we need. And then next, after that, we will let sort of the tool process that. And after the processing, going to the third step, we can see now it has been processed. It has gotten sort of all the data now. It is presenting it in a nice tabular format. The details are exactly the same. The listing ID, the host name, and then we have the text that we have seen just now. And on top of that, we can see that the tool now has already added additional enhancement here, which we can see in terms of enriched text sentiment. So one, it is giving a score between 0 to 1. So 1 meaning that it's a positive sentiment, 0 meaning that it's a negative sentiment. So anything above 0.5, it will classify that as a positive sentiment. So we can see that it now becomes very easy, right, for a machine to analyze text and then be able to give the sort of a sentiment analysis to say whether this text is a positive or not. And once that is done, we can even move further, right? So beforehand, we can have already, in my example, we have already uploaded 101 different review documents like that. So you can see this is one of the document that was being sent. We have 101 of such documents, and all the sort of sentiment has been already properly text and enhanced to each of those documents. And with that, now we can then do a query search, right? So out of the 101 review documents, now I want to find, or I want to examine more, which are all the documents that is negative. So I can do sort of a simple a query. So this is just to say that this is the label here, and we wanted to say anything with negative labels, please do a search for me. So out of the 101 review documents, we can find out that, oh, actually 10 of these reviews are actually negative. So essentially the results will be shown, and we can know which are the review numbers that are negative, and we can then delve in or dive in deeper to understand what was the reason of those documents that are being negative. Yeah. So that's the first tool that I like to introduce, which is the one on NLP, particularly sentiment analysis. So now I would like to move on to talk about the second category of tool, which is essentially building a chatbot. This is on IBM Cloud, on IBM's Watson Assistant. So typically to build a chatbot, we need three main components. Okay, so one is the intent. We need to understand whenever a question, or the chatbot needs to understand whenever a question is asked, what is the question, what is the person actually trying to do? What is the intention behind the question? And we need to identify some entities. So we need to identify if there's an object or there's something that is being asked, something like a menu or order number. We need to identify it effectively and link it there. And the last part is we need to create a dialogue flow. So essentially, it will be a question and answer similar to the example I gave about Siri. If you ask a question or you have a greeting, it should be able to greet you back. So over here, we can see this is a preview, something that has already been built. So you can see it's quite easily customizable. Just setting up the flows and all that in this user-friendly interface, and we have a chatbot. So I shall go through the flow and see which are the components it is touching on exactly. So here we have a user, that's me, who say, hi, good afternoon. So immediately, the chatbot has already gone back to the intent. And with this kind of a text, it identifies that, oh, okay, this is a general greeting that is being fed. So the bot will then say, yes, good day to you. And then after that, the question that is being asked by me is, what is your menu? So immediately they will get the intent that, oh, I am trying to understand more about the menu, and it is something about the menu entity. So immediately it will reply through the dialogue flow, through the menu dialogue flow, to say, what menu would you like to see? Is it vegetarian, cake shop, and standard? So this is based on just a selection. So once I selected cake shop, automatically the dialogue flow have a if else statement, and then it will direct me to the cake page on the website. And similarly, I will ask, how do I cancel my order? And then it will sort of give the details about the order cancellation, and then ask about the order number, because now it understands the intent is about cancelling the order and it's related to the entity of a order number. So that's essentially how the chatbot looks like. Or I'm sure many of you have also interacted with chatbots in one way or another on government websites, banks, shopping websites, and you can even find a chatbot on IBM's website as well as NTUC learning website. So based on this, actually underneath the hood is really just these three key components, and in a lot of the tools nowadays, it has been very easy sort of to set that up. So in the next slide, I would then like to share more about how it has been applied practically, right? So this is our Watson Assistant for Citizens, which essentially builds on the Watson Assistant chatbot tool that we have just shown. And it has provided citizens with the latest updated information on COVID-19. And it has now been employed in more than 25 countries around the globe. So now let's take a look at the video to find out more. Yeah. So basically, with the onset of COVID-19, citizens were faced with the uncertainties of COVID-19, and that led to an overwhelming demand for COVID-19 related information. The challenge, however, was that the existing infrastructure of emergency phone operators, representatives, client customer officers could not really help or could not really meet up with all the overwhelming demand, especially when the information are updated at a very fast pace, and some of them may not be relevant anymore. So as you can see in the diagram here, that's where actually a chatbot came in to be very effective, because now you can be able to get the information 24/7, and you can always get the latest available information that is updated into the tool. So that's where the chatbot, or this IBM Watson Assistant for Citizens, actually came in to solve the problem. And the first version of that was able to be deployed in just a week. And now, as we can see, this is the backend interface of the chatbot tool. So this is very similar to what we have seen earlier, right? The intents, as you can see, entities, dialogues. So that is the same sort of infrastructure that is powering this chatbot. And I think sort of the takeaway that I really wanted to show here is that many of those tools today that are being used are of enterprise grade and often can be deployed directly. And because of that, it can be deployed at a very fast manner, and it can be started up in a very fast manner. So like I mentioned, that this Watson Assistant for Citizens can be just deployed and sort of customized to the local context in just a week's time. Because one, it is very easy to customize, and then second, all the tools are already pre-made. There's just some sort of minor tweaks to enable it to be fully workable, or to be fully workable in the local context. Yeah. So that's essentially the chatbot tool. And next, I like to move into the third category. The third category of tool on AutoAI. So AutoAI has been a hot topic in recent years. And what AutoAI is really useful for is especially all those well-defined machine learning problems. For example, predicting prices based on contributing factors, classifying fraud, and so on. Those will be where AutoAI will be really useful. And essentially, the benefit of AutoAI is really it enables both experts as well as beginners to greatly cut down on the time required to run this type of a standard or repetitive machine learning task. And how it is done is really being able to apply some of the standard rules and best practices. So in this case, you can see that this is the whole machine learning pipeline. And AutoAI, based on sort of, I think, I would say the machine learning that has been applied on many of the tasks. So all of those modeling techniques, feature enrichments, hyperparameter optimization has already been sort of coded into AutoAI so that it knows a few parameters to explore and I would say to explore and apply sort of for a sort of common task. And it is able to then sort of automate this process. So a lot of times after the task has been very established, this becomes very repetitive. So AutoAI is able to do that in an automated fashion. So that really saves a lot of time. So you don't have to go through the whole chain all over again. And AutoAI will be able to optimize or automate a lot of those for you. So now let me take an example of a fraud identification banking context to illustrate this. So in this sample, we have a training training data set of 828 observations. And on the first column, this is all the different parameters being fed to it. So all these are sort of the parameters, and this is sort of the end label to say whether the case are at risk or not at risk. And after that, we have each of the case, which each of the parameters and the necessary labels. Okay, so essentially the next step, we will feed this into the AutoML program, which will then run automatically to go through the end-to-end machine learning pipeline and recommend the best working model. So I will explain a little bit more. So now we can see that the AutoAI algorithm is running after the data set has been fed. So just now, if you recall from the data set that we have been fed, right, we actually need to identify for them to say, hey, what are you sort of predicting on? So we have tell them that, oh, the column is actually risk, and then this is a binary classification. So binary meaning this is 1 or 0. So essentially they are predicting something that is risk or no risk. And we have already set sort of the matrix that we wanted to score them on, and that is based on the accuracy parameter. So you can see now just less than 2 minutes have passed. The data has already been fed in. It has already done sort of the initial training. It has already done the initial optimization, come up with the model. Yeah, and then it is now testing different models and iterating through the process. Yeah, so So this is sort of what the end outcome will look like. So it has gone through sort of the entire pipeline, and it has, P1, P2, meaning pipeline 1, pipeline 2, and so on. So now it has done sort of 8 different variations, and it has identified that, oh, pipeline 8 is actually the one with the highest accuracy score. So we can see here, out of all the pipelines, this has the highest scores. This was the algorithm that was being used, and these were the additional enhancements on the hyperparameter optimization and feature engineering. And immediately this model that has been trained can then be deployed and be used for identifying or classifying new cases. So you can see that, AutoAI really saves a lot of time, and even is good for experts to save time, and it's good for beginners as well. So you can just feed it in, and then you can get an overall sense on what algorithms typically work well on this situation, and you can sort of continue to tweak from there, or use the already trained sort of a model. So that really simplifies a lot of things. You can see that throughout this process, there is no going into complex coding. There is not really any coding involved. It's just click, identifying the parameters and so on. And everything is done in a automated fashion to at least give the first cut. And this will be very useful, especially for all those very standard machine learning problems, which the AutoAI has been well optimized for. All right. So in the previous session, so we have looked at some of the modern day tools like sentiment analysis, chatbot tools, and AutoAI tools. Particularly, I have used the context of IBM Cloud, but you can expect that similar tools exist on other clouds as well. And we can see that it is very easy to use. So in the following section, I'll then introduce more about the training initiatives that NTUC Learning Hub and IBM are collaborating on. And this can be a potential resource for those who are interested to take their next step on their learning journeys. All right, so what is this collaboration all about? So essentially, we are bringing our IBM Skills Academy courses and making them available on NTUC Learning Hub. So the first course that we are launching is this artificial intelligence course. So let's now take a quick look at the curriculum of the artificial intelligence course. So the course starts off with some overview lectures about AI landscape, the industry application, then deep dive into some of the key AI areas like vision, machine learning, language, as well as closing that with the future trends in AI based on our latest research and developments. And in between the lectures, you can see those components highlighted in black. Those are hands-on labs, sort of to reinforce the concepts in the lectures and provide the experience to build enterprise-grade solutions using IBM Cloud. So the 3 tools which were shown earlier will be covered as part of these lab sessions, and there will be many additional tools that you will be exposed in the labs. So what are the objectives of our course? So the objective of our course is really one, to bridge the gap between technical skills and industry applications by providing insights into how these technical tools and technologies are applied in the industry today. Also, our course is meant to be holistic and cover a wide scope and on an overall appreciation and understanding. So it will give you really a wide understanding rather than going deep into any particular topic or specific technology. So who are the main groups of people we find suitable of the course, and who are the people that we are targeting? So the first group of people will really be those who are starting out with no prior knowledge of AI and ML and like to have a good appreciation and coverage of AI techniques and technologies today and how is it applied in the industry. The other key group of people that we are focusing at will really be professionals who now have some basic understanding of AI and ML technologies, but would really like to understand more, especially about the applications of such tools and technologies in the industry today. So next, I'd like to highlight what are the highlights of our course, or what makes our course special. So one, I think is So one, I think, is really the blended learning approach, whereas we have seen in the curriculum earlier on, it is a blended approach where lecture contents will be mixed together with hands-on labs, and in between we will be sharing many of these industry case studies as well. And second thing, staying close to this idea of bridging gaps in terms of industry applications, the course will be conducted live by instructors who are AI practitioners themselves. So in addition to those case studies and hands-on labs, the instructors will also be able to share their personal experiences and be able to give you an insider view of the industry today. And also to ensure that you are learning the latest and most relevant content, IBM Skills Academy performs frequent reviews and update to the course on a regular basis. So for example, in this artificial intelligence course, there was just a major update in March of this year. So you will be sort of having the access to the latest content that has been refreshed and revamped. Also, the last point is that this course being sort of shared from IBM Skills Academy, it is the same content that IBM Skills Academy is providing to numerous universities across the globe to help students bridge the gap between classroom knowledge and industry knowledge. So you can be assured with the confidence that the content has been thoroughly vetted and validated by established institutions globally. So now we are coming to the end of the materials that I've provided for today. I'd like to share a parting thought on what might be a good strategy on the next steps of learning and skilling. So first, I'd like to share on this illustration on the left, which is taken from the book Atomic Habits, and this is a book I highly recommend. So essentially, what this chart is trying to represent is the benefits of applying daily consistent effort. So what is showing here is just if we just apply or be 1% better every day. So you can see at the end of a year, 365 days, we would then be 37% much better than where we have started off with. And we can also see that the growth is actually not in a straight linear kind of a fashion, but is in a exponential fashion. So this is similar in my experience as well. So it's really when I started learning, the investment might be insignificant at the start, right? Like when sort of learning first get going, it might not seem very applicable. A lot of the times we are just learning on the basics. But as the new knowledge start to stack up on the previous knowledge, as we start to understand and link different concepts from the different learnings that we have, then we can really sort of start to see the exponential growth as we try link topics together, as we start to build on our skills and knowledge. So with that, I encourage sort of all of us to take a daily consistent effort towards learning. And for those of you who are interested in this AI course that we have just spoken on, so you can actually, one way, go to the NTUC Learning Hub website, and if you just search for IBM, immediately you can see this artificial intelligence and machine learning course that is presented here. So those will have the more of the course details for you. Also, I think all of you who have signed up for the webinar today, email with further details on the course will also be sent with you as a follow-up from NTUC Learning Hub. Also, for those who would like to connect and keep in touch, you can find my LinkedIn details below. Yeah, so I think once again, I'd like to say a big thank you to all of you who have taken time off your busy schedule to join us for the webinar today. We will now move into the Q&A session